Let's go over fundamentals of probability. This will be a two-part video series. So we'll learn about outcomes and events, we'll express probability mathematically, and we'll identify the differences between theoretical and relative frequency probability. Okay, so outcomes are the most basic possible results or observations of an experiment. For example, if you toss two coins, one possible outcome is heads and tails, and the other possible outcome is tails heads. Typically, when we're dealing with probability, we're dealing with the outcome that we want to happen. An event consists of one or more outcomes that share a property of interest. So for instance, if you toss two coins and count the number of heads, the outcomes of heads and tails and heads both represent the same event of one head and one tail. Okay, so example 1, outcomes and events. Consider a family with 4 children. List all possible outcomes for the birth order of boys and girls. If we are only interested in the total number of boys in the families, what are the possible events? So for this problem, we need to list out all possible outcomes. So typically when I do this, I have some sort of order going on, but I would start with boys or girls and then go from there. So you could have, for instance, girl, 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 boy, and so on and so forth. On the next slide, I have this written out in a chart form. So you could have all 4 girls, you could have 3 girls and 1 boy, and there's 4 different ways that could happen. You could have girl, 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 boy, girl, boy, girl, 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 boy, girl, so on and so forth. You could have 2 girls and 2 boys, 1 girl and 3 boys, or all 4 boys. And so these are the possible combinations. If we're only interested in the total number of boys in the family, what are the possible events? So in this case, there's 16 possible outcomes. If you add all this up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. But the possible events that we're looking for, if we're interested in the total number of boys, would correspond to what I'm putting in the blue dot. So all of these events contain having boys in the family. Okay? So that's the difference between outcome and events. There's 16 outcomes, but only 14 of those correspond to boys in the family. So properties of probability. So the probability of an event expressed as P of whatever event we're talking about is always between 0 and 1. So the probability, what it means to be inclusive, is that probability could be exactly 0, not going to happen, impossible, or 1, which is 100% chance, for sure, certain. Theoretical probability. So theoretical probability is the likelihood of an event expressed as a ratio of the favorable outcomes over the total number of outcomes, or the events you want over how many are possible. So with the example of the 4-child family, the events or the favorable outcomes would be boys, and then the total number would be 16 of how many possible outcomes there are. So theoretical probability is what we expect to happen. So the probability of flipping a coin and obtaining a heads is we expect that to be 1/2, 50-50 chance. So probability of A or some type of event is defined by the number of ways A can occur divided by the total number of outcomes. So assuming an equal chance of having a boy and a girl at birth, what is the probability of having 2 girls and 2 boys in a family of 4 children? So we already talked about the outcomes for this one in the table. So we would write this as P of 2 boys and 2 girls. So this is what we want. And so if we go back to our chart, 2 boys and 2 girls has 1, 2, 3, 4, 5, 6. There's 6 ways that can happen over the total number of outcomes. So 6 over 16, which is 3 over 8, which is 0.375. Okay, or it's written out here again. Okay, so of the 16 that are possible, 6 give us what we want with 2 boys and 2 girls. So our probability would be expressed as the ratio of that, 6 over 16, or 0.357. Relative frequency probability. So another way of determining probability is to approximate the probability of an event by making observations and counting the number of times event A occurs. So this is called the relative frequency method or empirical method. I've also heard it called experimental probability. So P of A, it looks the same, but it has to do with the number of times A occurred and the total number of observations. So an example of relative frequency probability is actually the weather forecast. So when the weatherman tells us that there is a 40% chance of rain, remember percents are out of 100. So what this is saying is the weatherman or the weather person is giving us the relative frequency probability. Out of 100 of days like today with the exact same condition, on 40 of them it rains. So that would be a 40% chance of rain. So actually the weatherman is never really wrong because it's a relative frequency probability. A subjective probability is based on intuition. It's usually an estimate and it's typically inaccurate. So an example of subjective probability, going back to the idea of children, is I knew a family that they had 3 boys. So they're like, oh, well, we'll definitely have a girl next. So that's subjective probability. They actually ended up with twin boys. So that's a case where it's like your intuition or what you think is going to happen. So approaches to finding probability. So theoretical probability is based on the assumption that all outcomes are equally likely, and it's determined by dividing the number of ways your event can occur, what you want to happen, over the total number of possible outcomes. Relative frequency probability is based on observations or experiments. This is what I kind of referred to as more personal, or another way to think of it is more like event-based. And then subjective probability is based on intuition. Okay. So which method would you use? So there's three examples here. So I'm 100% certain that you'll be happy with this car. Based on government data, the chance of dying in an automobile accident during a 1-year period is about 1 in 8,000, and the probability of rolling a 7 with a 12-sided die is 1 over 12. So the first one, I'm 100% certain you'll be happy with this car. That's subjective probability. That's probably a salesperson trying to get you to buy the car, or just what they've experienced in the past. Okay. Bullet point number 2, the chance of dying in an automobile accident. So the way that they've gathered this is based on what's actually happened. So this would be relative frequency probability. Okay. And then the probability of rolling a 7 with a 12-sided die is 1 in 12. Thank you for watching. If you have any additional questions, please feel free to reach out to me.